Good afternoon, everybody. Today, thanks for joining me to this talk. I am going to talk about the SimLM, a game changer for the Lightning Network development. My name is Fernando. I am a Libreria Satoshi grantee for contributing to Lightning Network open source projects. I have done some contributions to SimLM and to LNDK. You can find my networks in those links. Today, we will explore why simulating the Lightning Network is so crucial, and how SimLM, an open source project, makes this process more accessible and affordable. This will take around 20 minutes with time for questions at the end. But before we jump into SimLM, we have to realize, I assuming also that all of you know how Lightning works, so I'm going to skip that. But building and testing the Lightning Network can be really tricky. So that brings us to why simulation is really important. I don't know if someone wants to answer why simulation is so important. Maybe someone has some experience about that in real node projects or research.
I can apply some simulation approach to translation to realize the different scenarios that might happen.
Yeah. Yeah. That way, it was difficult to do that.
Yes.
Yeah. Usually, simulation can be kind of tricky. So let's see how can that be improved. So before we dive into SimLM, let's talk about why we need to simulate the Lightning Network. So Lightning's decentralized nature with multiple nodes and channels interacting dynamically makes this real world testing really difficult. It's like predict the traffic in a city with no map. Running real nodes also can be really, or requires a significant amount of computer power, also energy and funds, which makes all this process really expensive and slow. And there are also a couple of use cases that can benefit from simulation. Protocol developers can test new ball specifications without risking real phones. Also, application developers could stress test their applications under more realistic conditions. Researchers can generate synthetic data for network analysis, like security or how routing or efficiency routing. At the end, a simulation let us mimic how real payment flows work, saving costs and resources. So all this need for testing inspired SimLM. So now we can meet SimLM. SimLM is a payment generator activity for the Lightning Network. The purpose is really simple. It tries to simulate realistic payment flows on any network, in any Lightning Network topology. It's really flexible. It can work with any Lightning Network setup, whether it's a SIGNet, a testnet, or even a local environment. Also has the capacity to support both mocked and real node nodes. More important, let lets you configure different payment patterns, such who sends what, when, and how much. You can find the CMLM repository in this link in GitHub. So now let's talk about the setting up CMLM. All the process is really straightforward, so I will walk you to through all these steps. First, there are a couple of requisites. First, you have to have a Lightning Network topology. Any topology works. You have to access to those nodes in order to execute some commands. You have to have installed RAS and Protoc. On all those nodes that you have access, you have to enable the key set feature. For example, here is how it's done in Eclair. But by the way, with CMLM, you can connect to LND, to CNN, and Eclair. Then the installation is also really straightforward. You only have to clone the repository. You have to create a JSON file where it's going to be located all the simulation, and then you can run it using the carword command, or you can use the make install, and which create a executable, and then you can run pointing to the JSON that contains all the configuration, all the simulation. So yep. Let's see now the real power that is behind CMLM, that is the configuration and how the simulation works. For the simulation, you have two modes. You can use the random activity that basically generates payments based on the topology that you have. What CMLM does is ensuring that all the liquidity stays balanced between all the nodes that are part of your topology. Also, the other mode is the specific payments. You can define the source, the destination, the frequency that the payments can be done, and the amount. A simple example could be something like we have access to nodes, one LND, Alice, and one CLN with Bob. We can define a simple simulation where we send from 2,000 sats between Alice to Carol every 1 second. So that is the power that has CMLM. And as I said, it has support for your any kind of topology that suits your needs for testing, and also you can suit also all the payment patterns that you want to simulate in your setup. So yeah, let's see kind of CMLM in action, how it can work. For this demo, I am going to use Polar, but this can be done in real nodes that you have access in, for example, in Kubernetes or on Docker. In this case, the setup that we are working on is 6 nodes in LND. Some of the nodes are connected and have channels. Others don't have any connection. And we can start creating all the simulations that we can see. For example, in this first simple simulation, we define the connection to 2 nodes, Alice and Carol. Here we have to define the public key, the address that we can connect, and the macaron and the assert. And then we define here the simple activity. We can use the alias defined before, and define also the interval the payments are going to be sent, and the amount between these 2 nodes. These are really a simple example that we can run. So we can see here how Simulent detects and connects to the nodes created in Polar. In this occasion, we didn't define how much payments the simulation has to done. So by default, the simulation is going to run forever. And is going to send all this amount until the liquidity is exhausted. Another example, similar to the previous one, but in this occasion there are two additional options which are optional. That is how the payment or the amount of time that the payments are going to start, and how many payments we want the simulation complete. Just in this case, we want only that the simulation complete 10 payments. Let me see this thing. Okay. So we can see here that the simulation is going started with a delay, and we have to see that it's going to only have completed 10 payments. As you can see, the simulation has finished with all the payments that we wanted. In this case, the payment code has been met with the number that we defined in the specification. Let's see another example. This one is a more complete, using all the nodes that we defined in Polar. Also, the activity is more complex. We using all the source and destinations, using different intervals, amount between those nodes. So we can run it. We can see that is going to connect to all the nodes, and the simulation is going to run with all the specification we defined here. Another example that we can see, let's see this one. In the previous examples, we use or we defined how the activity or the payments are done. But as I said before, we also have the option to just run it in a random mode. So we don't define the activity, and we let Simulent to, based on all the network topology, generate random payments using different probabilistic functions. So all the balance keeps active. So for example, this one is the demo file. Yeah, in this occasion, we don't define any kind of activity. Simulent, using the random feature, selects how many seconds the payment has to start, also the amount. All these output can be used later on. So researchers can use it to define if there is a kind of security problem, or also to see if the routing is working efficiently. The final example is more related with the mocked nodes. In the previous example, we use all the nodes defined in the Polar version. This can be a really slow process to define, as I said, all the key send feature, and also time consuming. But the other option that we have with SymLM is to use mock nodes and define how all those nodes are connected, and also all the parameters that we can create here. For example, we can define the HTLC count that each node or each channel between those nodes has. Also the spire delta that node has also. For example, we can run it. Desde demo 6. So in this occasion, we don't connect to any real node or local node, and install this SymLM will define all the mocked nodes, and also using the random functions is going to start with all the generating all the payment flows that will allow us later to analyze how the network is working. So based on that, we can define some advantage and limitation that SymLM has. One advantage is that SymLM is really lightweight, flexible for various network size, whether it's a SIGNet, a testnet, or a local environment. Also is open source. You can use it, and it's community driven. Most importantly, it helps you to reduce costs compared to real node setups if we use the mock setup. So limitations, we use the real nodes. We have to have access to the nodes. We have to define the key set configuration that it might have need some setup. Also, mocked networks or nodes might not be fully replicate real-world quirks that can be useful to have. That is something that is necessary to improve. Well, you have to have Rust in order to install SymLM. Based on all that, we can say that SymLM is a really powerful tool for simulating the Lightning network. It also can be work for developers, for researchers. What is important because it enables scalable and cost-effective testing without risking real node phones that can be difficult to have. Yeah, the next steps, you can explore the repo. You have any kind of question or something that we can improve, you can create an issue. Yeah, try it in your next Lightning project, so we can have a more experience with that and see how we can improve it. Yep, that is all. Thank you for your attention. You have any questions?
Hi, thank you for your talk. Really interesting. If we would use this for stress testing, the big question I have is what are like realistic network conditions for, say, a beefy routing node? Does the SymLM project make any suggestions for what would be a realistic scenario to test on a routing node?
Yeah, thank you for your question. That's a really good question. no, right now we don't have we are defining that, but yeah, it could be useful to have a README so we can indicate people how to create those conditions in order to test those stress tests. Welcome.
So, thanks for the presentation. I saw that you have mock nodes. Can you export some data of what's the state after the simulation on those mock nodes compared to the other one?
All the output is gonna be saved. You can define with extra parameters where that output is gonna to be created. So after that, you can see all the state. Also, one thing that is also interesting with SimLM is that you can use the same seed in order to have deterministic output. So you can change your nodes. For example, this works for the mocks and the real nodes, and then you can run it again using the same seed and have the same results. So that will help you later on to see if there's something changed, you can improve.
Thanks.
Any other questions? Okay, well, thank you, Fernando.
Thank you very much.